Hello and welcome to the Dragonfly Daily. I'm your host, Mike, the only person in my company foolish enough to think we can deliver fresh webinar content every day during a pandemic. Today's the topic is working with graphs. We're going to look at a topic that probably most Dragonfly users don't actually use, but it is useful for a number of different domains and applications. If you're watching this on YouTube, hit the subscribe button. That way we will know you're interested and you want more content. If you like this particular content, hit the like button as well. Just a reminder, this is the content for this week. We've already done these webinars and put them online. They are all available on YouTube. Today we're doing working with graphs, or something called skeleton network models. And then tomorrow we start the topic of image segmentation and then Movie Maker on lesson 5. Reminder, if you're watching live, you can catch it at this time, and you can also ask questions at the end of the webinar or at the very, very beginning of tomorrow's webinar. Please, 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 if we can take some of this community of people that are using Dragonfly and allow us to help each other and answer each other's questions in the forums, then everyone's going to benefit. So please take a look at using the forums, post questions there, answer questions there. It'll be really beneficial. And as I say just a few minutes ago, Dragonfly Daily webpage will be coming soon, and there you'll be able to see the data that we're using in each different lesson, and you'll also see where you can request topics for future lessons. So dive into lesson 3, working, it says working with meshes. Oops, that should be working with graphs, skeleton models. We are using Dragonfly 4.1. We're using the out-of-the-box experience for Dragonfly 4.1. So if you download and install Dragonfly 4.1, you will be able to follow along and do all of these activities. The agenda for today is, well, right now I'm going to spend 10 seconds telling you some applications of graphs, and that might include pore network models. You might be looking at roots. You might be looking at vasculature in plants and animals, maybe even neuron connectivity, anything where you can represent your data maybe as balls and sticks, where the balls are connected with sticks and maybe they branch. That's what graphs or network models are good for, and that can be a useful way of representing and interrogating your data. So a graph is just that, balls and stick, vertices and edges, but the vertices can store data. We're going to see how you create a dense graph in Dragonfly, how you create a sparse graph, what that means. We're also going to look at measuring connectivity, tortuosity, maybe a few other properties, and how you can render a graph, how you can change the color and the size of the nodes and the edges. We'll also very briefly create a graph with a plug-in, a tool called OpenPNM, the Open Pore Network Modeling Toolkit from Jeff Gostick and co-workers at University of Waterloo. And finally, we'll probably save our graph as an ORS object. All right, let's go over to Dragonfly. The data set that we're working with today is something that I created on my own. It's a derivative of a SandPack data set that comes from the Digital Rocks portal. This data set will be hosted shortly on the Dragonfly website, which is to say, if you go to ORS Dragonfly and you pop over here to the website, if you look under Learn, Sample Data Sets, here's the data set from yesterday, the grains mesh. Oh, hey, it's already here. Here's the data set from today, so you can grab it right now. It's called Graph of Small SandPack, and it's just 5 megabytes. It'll download pretty quickly. So that's the data set we're going to work with, and I'm going to open it now. Now, instead of importing image files or importing mesh files, today I'm going to use the Import ORS Object button, which occurs right here. It may also be over here. Import objects from file. I'm just going to click this button. Now I'm going to navigate to my downloads folder where I have this file called graph test case and sandpack.ors object. When you open an ORS object file that has more than one object, you will see a checklist like this. This particular ORS object file has a shape, and it has 2 graphs, and it has an overlay, a couple of regions of interest, and data sets. Don't worry if you don't know what all these things are. We haven't gotten them to all of them. We're only on day 3. I'm not going to import the graphs because we're actually going to compute those on the fly during today's lesson. I'm going to import everything else, click OK, and now it's loaded all the data. As I mentioned, the data set that I'm working with today is just a small subvolume of a SandPack that comes from work done by Masha Pradanovich's group, which happens to be hosted in Masha Pradanovich's Digital Rocks portal. Check it out. If I click on attribution, here are the data. Here's what you need to know. This comes from a data set called hydrite bearing sand, and here's all the information you need, and here's the information on the Digital Rocks portal. That's an attribution. It's something in Dragonfly called an overlay. We can show you in another lesson how you can do your own overlays. So I have a data set here that is my sand pack, and you can see I've got these little grains of sand and they're surrounded by air. I also have two regions of interest. We haven't covered that topic yet. We'll start digging into that tomorrow. Two regions of interest, one called sand grains, which is labeled the pixels that belong to the grains of sand, and one called pore space, which is labeled the pixels of the pore space. Now, what I can do in Dragonfly is I can right-click on the pore space, and these are all menu items that you'll see when you click on an ROI, something we call a region of interest. That's a data structure for segmentation. What I'm going to do is I am going to go down to 3D modeling, and I'm going to choose, first I'll choose get skeleton of ROI as graph. That's a bit clunky of a title. This creates what we refer to as a dense graph. In fact, I'm going to double click this, and I'm going to rename this dense graph of pore space. Now, this creates a data structure called a graph, and I'm actually going to come down here, whoops, and I'm going to choose a multi-view layout so that we'll have a 3D view, and I'm going to double click in the 3D view. So we can see my sand pack. I'm going to turn on the visibility right here of the dense graph. All right, so what we have done is we have created a skeletal graph data structure. It might be called a network model. And this is a connection or a set of nodes connected by edges. And sometimes those edges connect at a node, and then that node forks, and you have a branch point. I will point out right away that Dragonfly does not visualize the graphs in 2D views. They're only visualized in 3D views. We may entertain some enhancements to that in the future, but for now, they're only available in the 3D view. Now, what you're looking at here is there is pore space, and there are big pores and there are small pores, and those pores are connected to each other by little channels. And so the network has analyzed the pore space ROI. So that was this pore space ROI. We could turn it on in 3D. And it's tried to position nodes in big pores and trace those pathways to other big pores. Really what's happening when I right click and ask for that 3D modeling, create a skeleton graph, it is taking this blue ROI and it's trying to thin it down to a little skeleton, so it makes a very thin ROI, and then it traces out a graph along that ROI. Now we call this a dense graph because every little pixel that was contributing to the graph gets its own node. And then, of course, you see the connection. We'll look at sparse graphs in a minute, and you'll see the difference quite clearly. So we have this graph object, and if you look over on the right, we saw on Monday or on lesson 1 that you have the property panels for images. We saw on Tuesday that you have the property panels for meshes. So here we are on lesson 3 looking at the property panels for graphs. Now, what we see down here is some information about the graph, how many vertices, how many edges. We also see that under graph settings, we can affect how the graph is visualized. So the graph has edges and the graph has vertices. Now we can change the color of the edges and the radius of the edges. So as I drag this slider, you can see the edges of the graph. And right now they're colored white. Now, the graph has all of these nodes all of these nodes along the graph, and they have a radius. Right now, the radius is mapped to a property called tortuosity. And so if we, let's say, hide the edges for a minute, what you may notice is that sometimes, maybe it'll be a little easier if I show the edges, sometimes going from this branch point to this branch point may take an indirect path. And how indirect is it is a measure of the tortuosity. So really, it's the curvilinear path as a function, or maybe as a quotient over the direct linear path, and that gives you the local tortuosity. So here is a node, and it's connected to another branch node down here, and so it's quite indirect and therefore more tortuous, and that's why it's a higher color here. Now, of course, the color mapping can be changed to different LUTs, so we could look at different ways of mapping the color. We're not going to explore that too much today, at least not with respect to tortuosity. Now, we can, for the edges, we can affect their radius and their color. For the nodes, we can affect their radius. It can be mapped onto a measurement. We can also affect their color. So And we can make more measurements. So for example, if I right-click on the dense graph, I might come down here and say, I would like to add a connectivities measurement that is, well, I'll do it and you'll see what I mean. So now I'm going to come down here and I'm going to change the radius based on connectivity. And now if I drag this all the way to the right, you'll see that these nodes here, this node, well, let's look at this node. It's connected to 1, 2. It has a connectivity of 2. This node has a connectivity of 4. It's connected to here, 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 and here. So this is a branch point. Here's a branch point of 3. I'm not sure what, that may be a branch point of 4 or 5. I can't really tell. But what you'll see is they're now sized by connectivity. And you could also color code them by connectivity if you want. Actually, that would make more sense. Let's do both. Yeah, so now we can see the yellow is connectivity 4, the green is connectivity 3, the blue is connectivity 2. If you had one that terminated in the very end, this has connectivity 1, and it's a little dark blue color. So we are color coding and scaling size based on connectivity. So you can see this traces out the pore network connectivity inside this pore network between these sand grains. Now, so as I'll just restate, we can color code and change the size of the edges, and we can change the size of the nodes and the color of the nodes. Now at this point, let's go ahead and create a sparse graph so you can see the difference with a sparse graph. I'm going to take my pore space again. I'm going to right click. I'm going to go down to 3D modeling. I'm going to choose create a graph from ROI. I think in the next version, those are actually renamed sparse graph and dense graph. I'm going to double click so I can rename this sparse graph of pore space. And I'm going to turn on the visibility. Now, so there's a lot going on. So I'm going to take these edges and make them a little bit bigger. And if you look, let's hide this one for a moment. So you see the difference in the sparse graph. It does not trace out all of the individual pixels that were connecting a path. It basically finds a branch point and a branch point, and it connects it by a single edge. So you can see that the edges can be colored. In this case, the edges have a parameter now, length. And so you can color code and change the size or the radius of the edge by their properties. So edges can have properties and measurements as well. So now we're looking at a sparse graph. And when you look at compare the sparse graph to the dense graph, you can start to see why some of these were more tortuous than others. So sometimes the direct path was quite short, and the actual path through the pore network was more tortuous, and therefore a higher tortuosity score. So Dragonfly allows you to make these measurements. You can also make and attach your own measurements. So I'm going to do something, we're going to do it rather quickly. Not all of you will follow along, but don't worry about that too much. I'm going to take my sand grains and I'm going to compute something called a distance map. So if I right click on sand grains and I go down to create mapping and choose distance map, I've created a new image. And this image is a little hard to interpret. We can do a whole separate lesson on distance mapping and distance transforms. But what you should see in here is, let's do this. I have my sand grains here, and this part of the pore space right here is the maximal distance from this sand grain. These pixels here are very close to the sand grain, these are very far. So my distance transform, my distance map is showing me for every pixel how far away is it from a sand grain. That can also be a proxy for how big is a pore. So if I'm really in a spot that's far away from sand grains, that must mean I'm in a bigger pore, because if you're in a very, very tiny pore, you won't have any pixels that are far away from sand grains. All of that is to say, if I come back to my 3D view, I can take my sparse or dense graph. Let's take my sparse graph. I can right click and say I would like to add a new vertex scalar value. I want to map values from an image in this case. So I choose this and it says which image, and I say the distance map of sand grains. Now what has happened is if I take my sparse graph and I come down here under the vertex measurements, both the radius for how big the vertices are plotted and the color, I can now map that onto the distance map of sand grains. And so I could use this as a new measurement. So you could put any sort of, you could encode any sort of measurement you want into an image, and then you could sort of extract that or map those directly onto vertices. Okay, so we've looked at the Dragonfly tools for creating sparse graphs and dense graphs. I will show you, before we move on to the OpenPNM graphs, I will show you that when you have a graph, you can also, let's take maybe the dense graph, you can click this button, and this button will show you the different values. So remember, we've got lots of vertices, and every vertex has a tortuosity measurement, or every vertex has a connectivity measurement. So this gives you the connectivity, in this case of your pore network model, which can tell you a little something about topology. I'm not a graphs or networks expert by any means, so I can't really interpret this for you. You can also look at the lengths of different nodes. And of course, in the dense network, the length is all pretty short. You can look at Euclidean length as well. So you can interrogate the different values of your pore network and export this CSV if required. Now, we can visualize, we can analyze, we can also construct them with another toolkit, which I'll describe now. So I'm going to go over to Tools, and I'm going to choose Pore Network Modeling. And if I have a graph selected, it'll throw an error message. You'll see what I mean. So I click Pore Network Modeling. It says, hey, the selected graph was not created through OpenPNM. That's okay. OpenPNM is an open source pore network modeling toolkit. As I mentioned earlier, this work is done by Jeff Gostick and coworkers. Jeff is now at University of Waterloo. A couple of his trainees, I think a postdoc and a graduate student, came over and asked ORS how they could put this into Dragonfly, and so they made it a plugin. And so please, if you want to use this, we can dedicate another webinar topic, but please, if you use this at all, please cite Jeff's work. We want to make sure that he's getting credit and his literature is showing proper citations. Now, there are different tools here in this plugin. I'm going to go to Network, and I'm not going to do very much today. I'm just going to go to my pore space, and I'm going to click this button. This is going to generate a pore network using the OpenPNM tools, and it's showing right now. So I can hide the image for a second. So this is the pore network. It's a sparse network, and this is generated by the OpenPNM tools. Interestingly, you can also, if you wanted to, you could generate a network based on the sand pack. So if instead I choose the sand grains, now, if I generate a network, this is really going to represent each sand grain as a node. And then if your sand grains are touching 2 other grains or 5 other grains, that connectivity measure will really tell you sort of about the packing and the crowding of the sand grains, or at least that's how I interpret it. So there's a rendering issue with this particular diameter. So I'm going to try and turn down, I'm going to tell it the edges I can just I don't care about seeing the edges of the sand grains. And then for diameter, or should I say for setting the volume here, well, those are the sand grains. If we look at the pore network at the same time, and let's take the pore network and drag the diameter really far down. So let's do this. I'm just going to take, I've got my pore network, and oops, I don't want that. All I really want to do here is pick a measurement that'll make my pore network edges look a little bit smaller. There we go. And I also want to basically hide the nodes of my pore network. And after I'm done, you'll see why. So I'm going to come down here where it says the size of the radius, and we'll drag this down. The reason I wanted to do this is this rendering right now, we're actually looking at 2 different network models. The spheres that you see here are my sand grains, and so you can sort of see how they're packed. And the edges that you see, those are the connectivity of the pore space. So now I'm looking at sand grains as one model, and I'm looking at pore space connectivity as another. As I mentioned many times before, you can have different measurements on the vertices and even on the edges. And while the Dragonfly graph generation tools only put a few measurements like tortuosity, the OpenPNM tools put more measurements. So you'll see measurements for area, diameter, equivalent diameter, inscribed sphere. So all of these measurements, we could probably color code them by position in the coordinate system. So you can read all of the OpenPNM documentation on the OpenPNM website about the different functionality there. Now, nobody on my team is an expert on how to use the OpenPNM tool, so if you do request a tutorial on that topic, I'll have to go and study up on it. So I can't do it tomorrow, for example, but we can learn it. You can do simulations here. So I think you can do sort of mercury intrusion style simulations and single phase permeability simulations on your pore network model. Okay, that's everything I wanted to do today, except maybe save a network model. So if I take these two models, if I right click on one, I can do export as ORS object, and then I can put in a file name, or I can select multiple graphs, or I could select both graphs and maybe the ROIs, and I'm holding down control while I click. So I'll have this multiple selection. Now I can right click and say export as one ORS object, and then when I go to import that ORS object, I'll see the checklist of everything that's encoded with it. All right, that's it. That's and I should have mentioned at the very beginning, graphs are new in Dragonfly. We introduced them in either Dragonfly 4.0 or Dragonfly 4.1. So there's not a ton you can do with graphs, but if you have this sort of data that can be modeled well with a ball and stick data structure, then graphs might be useful for you. Okay. That's it for the day. 25 minutes, still a little long. We'll see if we can make these shorter in the future. Now I'm going to go to the questions, and we'll take 5 minutes of questions. I have a question. Okay, let's see. Let's go to answered questions, open questions. And can the software generate tetrahedral meshes? So I think we answered that at the beginning. You cannot generate tetrahedral meshes or solid meshes in Dragonfly. Annika asks, can you add extensions? Absolutely. So Dragonfly has got tons of tools. So OpenPNM is an example of a very rich extension. If we come over here, there's the dev.dragonfly. No, that's not right. Let's try ORS Dragonfly. Maybe it's one of the top. No, it's not one of the top Google recommended pages, but you can come here under Learn and choose Developer Documentation, and then we can say Dragonfly 4.1. This is the developer documentation. You can write code in Python, you can write code in C++, you can write new image filters, whole new extensions like the pore network modeling tools, you can write new macros. In fact, if you look here under extensions, here are the different ways you can extend Dragonfly. Plugins, new property panels, new filters, new filter banks, new objects analysis statistics, which we'll have a look at tomorrow. Next question, and we can have a whole webinar topic on adding extensions. Next question is, the data set is not downloading. Oh, well, if you can't download the data set, I'm gonna look in and test that. My colleague uploaded it sometime in the last hour. So if it's not downloading, we'll troubleshoot that and figure it out for today. Next question is, how can you hide the yaw, pitch, roll, etc.? Okay, so what that user is asking is, if I come to this view and let's turn on the image. It's a little bit brighter. Let's go here. You see I've got this black text showing up. That is my yaw, pitch, roll, all of these text presenters. If you go over to the main tab and you find this panel called Scene View Properties, there is this checkbox, Show Text Presentations. So that can turn it off. You can turn it off or on. We don't have any fine-grained control where you can turn off individual ones and leave others on. Next question, can we export the processed data as text or CSV for replotting in Origin? I don't know what Origin is. The data can be exported as CSV, although I've been told there's a bug in Dragonfly 4.1, so you may have to wait till Dragonfly 2020.1. With any luck, you'll see that in this webinar series later this month when that download is available. You can also go to the Python console, and in Dragonfly, now we can probably put this in the forum somewhere because we've had this question from another user. You can always say something like, let's make the text a little bit bigger. my graph equals, and then you can take one of these things like my sparse graph, and now I have a reference to my graph. If you wanted, there's a format called network X, which is I think I have that right. Let's see, if I do my graph X equals my graph as my graph, oh, maybe get as, these are all the functions that are available, and there are very many of them. How do I see all of them? Well, I'll have to get back to you on that, because there is a function here to get your network as well as ROI, but there's also a function to get your network as a network X, which has a very, very large Python library for handling network and graph models, and then you should be able to export it as a CSV from there. Next question, definition of dense and sparse graphs. So the sparse graph is the graph that has only nodes at where the nodes branch. So what you're looking at here is our sparse graph, and then if we overlay the dense graph, you'll see that the nodes actually, we should overlay the corresponding dense and sparse graphs. So there's my sparse graph, and there's my dense graph. So the nodes here are the same, but instead of having a single edge, it actually shows the intricate pathway. So the sparse path is a simplified representation. Next question, is there a limitation on the size of the stack for doing the graph? That's a great question. So we have not done that scalability analysis. I'm going to ask one of my colleagues if we can do that and figure out what's the maximum image you can take. And it's probably related to the complexity of your ROI that you start with, or maybe from how big the biggest pores are. We're going to have to look into that. It's a very good question, and I hope we can readdress that. What's the biggest input you can use for generating a new graph? Next question, is it possible to simulate fluid flow using these pore spaces? So yes, if you're using the OpenPNM tools. I don't know how to use them yet, but we can get together some documentation on how to do that. So if you want to do pore network modeling and you want to do, as I mentioned, single phase or absolute permeability measurements, you can do that. They're simulations. You can read. There's all sorts of people who have done this in the literature using pore network models to simulate fluid flow. So for some samples, it's a very good simulation. For others, the pore network model may be too much of an abstraction, but it's computationally cheaper than a lot of the more complicated simulations. Okay, someone asked about pore size statistics. So you can get the pore size statistics out so if you have computed volume, for example, so if we look at this graph of the pore space, I think among the measurements we have here, let's see, do we have volume? I'm gonna have to look into this. I don't see that the measurements on the OpenPNM are being reported properly. If we come back to I think I did it on the dense graph. Let's see, did I do it on the dense graph? No, let's do the sparse graph. On the sparse graph, I computed distance from the grains, which is a proxy for volume. And here I can get, I chose edge scalar values. I need vertex scalar values, and here's the distance map. And so I don't know that you can export this as CSV. I think when you save this, it just saves the figure. So we can address that. Well, like I said, maybe we should put that in the forums, how to export it as a CSV. All right, I think we've got time for maybe one more question. Can you repeat an application for graphs like these? Well, I'm not really sure what that question means because there's no picture in the question. So we'll take one more question. Interested in creating an ROI like you used today. Will you cover this tomorrow? Sure. We'll take this data set and we'll show you how to create these particular ROIs. Then you'll know how to go from a data set like this to this kind of ROI, and then of course to the graph, since we saw that today. All right, everybody, thank you for your attention. So please engage in the forums. Please go to the website and request topics for future webinars and vote up the ones that you do want to see. And please hit the like button if you're watching this on YouTube. So we really appreciate your participation. Thanks, everyone. Have a great day. Enjoy Dragonfly, and do your best, stay healthy, and best health to all of you and your family. Take care, everybody.